Hello everyone, I'm Shanti and today I'm here to present the ADTA 5550 final project presentation. The part 1 is to describe an image dataset, and I have selected the waste classification dataset that contains images. This dataset is obtained from Kaggle, and the dataset I have selected is about waste management. I selected this because most of the plastic which is going to landfills, it's creating more pollution and increasing toxins, and consumption of toxic waste by animals is really harmful. So I found it interesting and took this data set, and this data set classified into two classes, organic and recyclable, and below are the two samples of the data set that describes the recyclable class of the data set. And this data set is divided into 85% of the training data, which consists of 22,564 images, and 15% of the datasets, which consists of 2,513 images. Coming to the part 2, we have asked you to get upload a data through the virtual machine instant and access it and perform analysis on it. So first thing is going to our Google Cloud platform and selecting the VM instances and right click on the SSH and opening the browser window opens this window where we have to go to the settings and click on the upload file, which pop-ups the menu to select a file. So here I have uploaded all the files, and I have used cp command to copy the data file to the Jupyter Notebook folder and CAFR10 data. Here I have created the CAFR10 data folder using mkdir. And after copying the data, I have used ls-l command to see what are the files in my folder. After that, I have opened the Google Cloud SDK shell and gave the command of my compute SSH and username and my project ID and the zone and the local host to open the Jupyter Notebook. And after executing this command, the putty opens, and after typing the Jupyter Notebook here, we'll be getting the link to open the Jupyter Notebook. So after opening the Jupyter Notebook, we can do our analysis and the data will be uploaded automatically. And part 3 is to build, train, and test the CNN CAFR10 dataset. This image explains the model of our diagram of the model. So the input image is given, and we have used two convolution layers and two pooling layers here, and the fully connected layers helps to classify the data, while the convolution layer helps to predict the features of the data. So coming to the coding part, like how we have executed the model, implemented it. So first we initialize after loading the data sets and doing all the pre-processing stuff. We initialize weights in the filter. We give a function initialize weights and initialize the weight. And we initialize the bias values, and we set up and perform convolution computation using the dot product of the input layers and weights that we have initialized here. And we set up a layer and perform computation using the dot product with the inputs, weights, and bias we initialized here. So, and we return the ReLU layer outputs. Coming to the next step, we create a function for the pooling layer and the fully connected layer, and we create a placeholder for the inputs and the labels of the inputs using the TensorFlow. Here I have to, as I have install the version 2 of the TensorFlow, I have to give the command as the compatible version 1 so that I don't get any errors. Coming here, we have created, as we have seen in the diagram, we require 2 convolution layers and 2 pooling layers. So first we created convolution layer here, and again we have created the pooling layer, and this is the second convolution layer, and this is the second pooling layer. Here we have reshaped, here we have used the flattening to reshape, or flattening layers to reshape output data from the last pooling layer. Here we have created the fully connected layer that accepts output from the input layer, and here we have created the drop layer to drop some of the input that it receives. The softmax cross entropy loss function is created to compute the softmax cross entropy between the labels and the predicted outputs. And we have created an optimizer to optimize the neural networks. And we have created the AI deep learning trainer to train the networks. And we have given the steps as 5,000. So it repeats the 5,000 steps. And we have given the batch as 100. So for every 100 steps, we will be getting the accuracy value. And executing this using the TF session, we'll be getting the following output. Yeah, this is the output where in the step 0 we have 10%, and step 300 we have 1.3%, and step 4,600 70.68%, and step 4,900 we have 70.94%. So we can see that at step 0 we have from 10% jump to 70.94%, which is really good. Like increasing the steps, we get the more accuracy, which states that. Well, the part 4 session is to compare the MINS data set to the CAFR data set accuracies. So comparing the accuracy of MNIST and CAFR 10 datasets, the accuracy of CAFR dataset is 70.94%, and the accuracy of MNIST dataset is 98.95%. The gap in accuracy is due to black and white images in MNIST dataset and the color images in CAFR, and also the number of pixels difference in both the datasets may cause the reason for the less accuracy. And also the size of the MNIST dataset is 28 into 28, whereas the size of the CFR is 32 into 32. These factors might be the reason for the gap obtained. The part 5 is to improve the above convolution network performance, as we have got only 70.94%. So let's see and redesign the network. So I've tried many layers inputting and seeing the accuracy. After many trials, I got best method, I have tried at least 3 to 4 different models, and I have got best with the 4 convolution layers and 4 pooling layers. And here we have given the code for each convolution and pooling layers. These are the steps obtained for the 4 convolution layers. At step 300, we got the accuracy of 47.89%, whereas at the step 4,900, we have got 73.8%, which is greater than 2.86% than the above model. So I would suggest this is the best model than the above model. Coming to the conclusion, through this project, I have learned working with images dataset and how the dataset actually divided into different classes and split into test and train, uploading the datasets to virtual machine in GCP, accessing the datasets from VM, and performing models in Python using TensorFlow and Keras libraries, and how the accuracy of the datasets vary with different sizes and color of the image, like black and white or color images. improving accuracy by trials of adding different layers in the above model. As in the above model, the accuracy increased by adding the extra convolution layers. And also, benefits of CNN is the ability to develop an internal presentation of 2D. This allows the model to learn position and scale in variable structures in data, which is important when working with images. So CNN is really helpful when we want to detect a particular feature in an image, and then classify using MLP, that is multi-layer perceptron. Yeah, this is the end of my presentation. Thank you for your time.